Alright, we're going to look at how to solve by substitution. Now with this first example, we have y equals an expression and then y equals another expression. And since both of those expressions equal y, we can make them equal each other. Now you just have a basic equation with x in one variable, so now we can solve. So we'll add 2x to each side. So 10x plus 7 equals negative 3. Then we subtract 7 from each side. So 10x equals negative 10. Divide by 10. X equals negative 1. So that's your first answer. Now we need to take this negative 1, plug it into one of our original equations to see what, to find what y equals. Really doesn't matter which one you pick. I'm going to use this one. So y equals negative 2 times x, but instead of x, I'm going to put negative 1 minus 3. The negative 2 times negative 1 would be positive 2, and then 2 minus 3 would be negative 1. So y equals negative 1. Now you can check it by using the other equation, plugging in x and y, and seeing if it's true. So y being negative 1, x also is negative 1, plus 7. And let's see if this is true. 8 times negative 1 is negative 8, and negative 8 plus 7 is negative 1. So that checks. So x equals negative 1, and y equals negative 1. Alright, with this next one, we only have one of them that is a y equals. So we're going to take this expression that y equals and plug it in for y in this equation. So negative 4x minus 7, and then instead of a y, put negative 4x plus 16, I'm going to put it in parentheses because it's a group, equals negative 16. Now we want to get rid of the parentheses so that we can solve the equation. And we'll do that by distributing the negative 7. So negative 7 times negative 4x plus 28x. And the negative 7 times 16 is 112 equals negative 16. Now we have like terms on the same side, so we're going to combine those. Negative 4x plus 28x would be 24x. Then we can add 112 to each side. So we get 24x equals 96. Divide by 24. And we get x equals negative 4, or positive 4. Alright, now let's plug this in to one of our original equations so that we can find what y equals. I'm going to go with this one right here. So y equals negative 4. Instead of x, we'll put 4 plus 16. Negative 4 times 4 would be negative 16 plus 16. So y equals 0. There's our second answer. Now we can check it by plugging both of those into the other ones. Negative 4 times 4 minus 7 times 0 should equal negative 16. Negative 4 times 4 is negative 16. 7 times 0 is 0. And negative 16 minus 0 is negative 16. So that checks. Alright, with this next example, in order to do substitution, we don't have either one of these equal to x or y. However, we can easily move this one around so that it is a y equals. And then we'll subtract 3x from each side. So y equals negative 3x plus 1. Now we can take this and substitute it for y in that equation. So 8x plus 3 times negative 3x plus 1, again notice it needs to be in parentheses, equals 5. Now we can eliminate the parentheses by distributing. So minus 9x plus 3 equals 5. Combine your like terms. Negative x plus 3 equals 5. Subtract 3. Negative x equals 2, but we need a positive x. So x equals negative 2. That would be your first answer. Now we'll take the negative 2, substitute it into either one of our original equations. I'm going to use the bottom one. So 3 times negative 2 plus y equals 1. 3 times negative 2 would be negative 6 plus y equals 1. Opposite of minus 6 is plus 6. Y equals 7. Then we can plug it into the other one to check. So 8 times negative 2 plus 3 times 7 equals 5. Or it should, if we're correct. Negative 16 plus 21 should equal 5, and it does equal 5. So that lets us know our answer is correct. Okay, with this example, we have a y equals negative 1. Well, we learned earlier that a y equals equation would be a horizontal graph. But with solving the system, there's one of our answers right there, y equals negative 1. Now we just need to plug it into the other equation to solve for x. So 6x plus 5, and instead of y, we'll put negative 1 equals 1. So 6x plus, actually, minus 5 equals 1. Then we add 5 to each side. So 6x equals 6. Divided by 6, x equals 1. And there's your second answer. Okay, since they're both equal to y, you can go ahead and make them equal to each other to start with, regardless of it being fractions or not. Okay, now, since we have fractions, look at the denominators. In this case, the only denominator is a 5. So multiply every term by 5. And that's going to cancel your denominator, leave you with negative x plus 0, which I'm not going to write plus 0. And then those 5's cancel, so negative 26x. Again, I'm not going to put plus 0. Then we can add x to each side. You get 0 equals negative 25x. So 0 equals x. Okay, now we're going to take that, plug it in to solve for y. I'm going to go ahead and use this one. Y equals negative 1/5 times 0 plus 0. Anything times 0 is 0. And then when you add 0, it's 0. So y also equals 0. Okay, I'm going to check this one now by plugging our solution into the other equation, y and x being 0. So y, put 0 equals negative 26 over 5 times 0 plus 0. Anything times 0 is 0, and when you add 0, it's still 0. So that is correct. Okay, there are actually 3 different types of systems of equations. All the ones we've been looking at up to this point are independent systems. There are 2 independent lines that do intersect at one point, and that one point is the solution that we've been getting, the x and the y. A dependent system of equations would actually be the same line. It may not look like it initially, but you can adjust the equations to where they would be exactly the same by multiplying or dividing something. And when that happens, that whole line is your solution, so it's an infinite number of solutions. And we'll look at an example of that in a minute. And then an inconsistent system of equations, that's when your slopes are the same, but not the y-intercepts, and you get parallel lines. When that happens, those parallel lines never touch, so you have no solution. Okay, let's go ahead and use the substitution to solve this. We have a y equals an expression here, so we'll take this expression, plug it in for y. So 4x minus, instead of y, put 4x minus 5. Notice I put it in parentheses, equals 4. Now we need to distribute this negative. So 4x minus 4x plus 5 equals 4. You've got opposites here with the 4x's, so you get 5 equals 4, which is impossible. 5 never will. It can't equal 4. So this is an example of an inconsistent system. And it has no solution. Now we could have seen that right away by noticing that the slopes are the same. So in this first equation, your slope would be negative a over b, which would be 4. And in the second equation, your slope is also 4. However, they're not the same equation because the y-intercepts are different. In the first one, your y-intercept is 0, negative 4. But in the second one, it's 0, negative 5. So because those are different, we know that they're parallel lines, not the same line. I put 5 here instead of 4. That slope is 4. Okay, in this last example, if we go to solve for substitution, we don't have an x or y equals in either one. However, this one we could easily solve for x. So x minus 3y equals 13, and then we can move the 3y to the other side. So x equals 3y plus 13. Now we can take this and plug it in for x. So negative 2 times 3y plus 13, again in parentheses, plus 6y equals negative 26. So negative 6y minus 26 plus 6y equals negative 26. Again, our y's cancel, and you're left with negative 26 equals negative 26. The difference is this time it's the same thing on both sides. That's true, it does equal. That's because this is an example of a dependent system. And you have an infinite number of solutions. Now let's go back and look at why that happened. Okay, if you look at this first equation, you have x minus 3y equals 13. Now this next one, I could divide everything by -2 to make that equal x. When I do that, I get x minus 3y equals 13. Notice they're the exact same equation. They're the exact same line. If you were to graph them, you would graph the first line and you would graph the second line directly on top of it. That's why we say infinite number of solutions, because every point on that line is a solution. We can't possibly list all of them. But at the same time, the solutions are contained to that line. The points outside of that line would not be a solution. So we say infinite number of solutions. It's not all real numbers. All right, and let's look at one more time at the three types. You've got the independent system. That's the ones you can solve. You find an answer for x, you find an answer for y. They have one real solution. Then the dependent system, that's when it's the exact same line, or if you try to solve it, you get a number equal to itself, the same number, which would always be true. So that's an infinite number of solutions. And then you have the inconsistent system. If you notice right away, your slopes are the same, but the y-intercepts are not. That means they're parallel lines, and you're going to have no solution because it's an inconsistent system.